Okay, this is practice 4C, and this is what electron configuration looks like when we go beyond 3p. And things start to look a little weird. We're going to follow this order. If you are trying to read this vertical axis, it shows the actual order in which these orbitals fill, and notice that once we get beyond 3p, the order starts to get a little weird, so make sure that you are following this, or you can simply fill these orbitals using this grid, and you just want to make sure you're filling the orbital that is next closest in energy. So here we go. Write the electron configuration and noble gas notation for arsenic. We're looking at the periodic table, and we know that arsenic has got 33 electrons. I'm getting that because the periodic table tells us that arsenic has an atomic number of 33. That means it has 33 electrons. So where are we going to put them? Let's use this grid. We're going to fill these in order of lowest energy. And so I'm going to start with a slash. That is going to indicate one electron. Here is a second slash in an opposite direction. That tells us there's a second electron that is filling in a different direction. So we've got 33 electrons. We've filled two of them. Here is 3 and 4. We're going to fill the two p's next. 5, 6, and 7. We're keeping them separate as long as we can according to Hund. Here is 8, 9, 10. Now there's no more room in the two p's, so we're going to 3s, 11, and 12. After the 3s is the 3 p's, 13, 14, 15, 16, 17, and 18. According to this chart, after you fill the 3 p's, we fill the 4s next, so here is 19 and 20. After the 4s's, we fill the 3d's next. Here is 21, 22, 23, 24, 25. Notice I'm keeping them separate for as long as I can. Here is 26, 27, 28, 29, 30. After 3Ds, we go to 4P, 31, 32, 33. And because these are still separate, we call these unpaired electrons. Let's go back to the question. How many electron-containing orbitals are in an atom of arsenic? Well, how many electron-containing orbitals do you see? I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Those are orbitals that contain electrons. Of these, how many of them are filled? How many of them have no more room for another electron? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of these orbitals are filled. 15. How many unpaired electrons are there in an atom of arsenic? Unpaired electrons are electrons that aren't sharing an orbital with another electron. 1, 2, and 3. That means that there are 3 unpaired electrons in an atom of arsenic. In what sublevel are the unpaired electrons located? They're here in the energy level 4 and the p-shaped orbitals. So we'll say they're in sublevel 4p. That's all you do. Up here it's also asking for the electron configuration and noble gas notation. So we're going to write those both. The electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. But if I wanted to write that as a noble gas notation, keep in mind that the noble gas that is closest to arsenic without exceeding the number of electrons is whatever that one is that ends 3p6. Well, that's this guy right here. That's argon. So what are we going to say? What is the noble gas notation for arsenic? Arsenic looks just like argon because argon ends 3p6, 4s2, 3d10, 4p3. Okay. All right, let's keep going. Write the noble gas notation for vanadium. It's getting right to the point on this one. Well, vanadium's right here with a total of 23 electrons. So let's get the electron configuration for vanadium. Let's get rid of all this. And we'll say, okay, here's vanadium. Vanadium's got a grand total of 23 electrons. Where are we going to put them? We're going to start at the 1s, 1, 2. Here's 2s, 3, 4. Now we're going to 2p, 5, 6, 7, 8, 9, 10. Now the 2p is full and there's no more room. 11, 12, 13, 14, 15, 16, 17, 18. We're going to 4s, 19, 20. And now we're going to 3d, 21, 22, 23. There are 3 unpaired electrons in an atom of vanadium. And where are they? Well, let's write the noble gas notation. I'm going to write it out longhand first. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. Well, which noble gas is closest without going over? Which one ends in p6? There's our buddy argon. So we're going to say that vanadium's electron configuration looks like argon's, with 4s2, 3d3 on the end of it. So how many unpaired electrons are there in an atom of vanadium? This tells us that there are whoops, that was supposed to be the highlighter, I apologize. 1, 2, 3 unpaired electrons in an atom of vanadium, so we'll write that 3. How many electron-containing d orbitals are there in an atom of vanadium? Well, they're right here. There are 3 electrons in d orbitals, so we'll say there are 3 electron-containing d orbitals. It says name the element in the 5th period whose atoms have the same number of electrons in their highest energy level that vanadium's atoms do. And look what it says. This question is just like number 5 from practice 4b. Let's go there. Here we are. This is number 5 from practice 4b. And the trick is that both fluorine and chlorine end in P5. How do we know that? Well, they both are in the same column on the periodic table, and that's because they both have the same ending electron configuration. So that means we're going to look for an element that's in the same column as vanadium, just 1 row down. So what element is in the same column as vanadium? Keep in mind that vanadium's in row 4, right? That's row 1. That's 2. That's 3. That's 4. What element would be in row 5, the 5th period, that is in the same column as vanadium? There we go. Niobium, this guy right here. So let's get over back to our actual problem here, and it says what element in the 5th period would have the same number of electrons in its outermost energy level, highest energy level? Niobium. Okay, write the complete electron configuration for the element with the atomic number 29. Well, which element is that? Going over to our periodic table, and it looks like the element with the atomic number 29 would be copper. So let's get the electron configuration. Let's get rid of all this stuff. And so what we're going to say is copper and copper has an atomic number of 29. So where are we going to put them? Start with the 1s, that's 1 and 2, 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Hang on a minute. 21, 22, 23, 24, 25, 26, 27, 28, 29. So write the complete electron configuration of the element with the atomic number 29. It's copper, and it's got an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. And that's the electron configuration. If you don't want to write it all the way out, here's the noble gas that is closest. That's our old buddy argon. And of course, after the argon electron configuration, it is 4s2, 3d9. Please identify the element described in item 3A. Copper. And it says, oh, that's the only thing for question number 3. Let's go on to number 4. How many orbitals are completely filled in an atom with the atomic number 24? Oh, that's a darn good question. Let's go over here and find out which element they're talking about. 24, that's chromium. Let's get the electron configuration so we can answer this question. So we know the atomic number is 24. We know this is an element called chromium. We're going to say we have 24 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So our electron configuration for chromium: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. What's the noble gas notation? If you want to write it like that, you could say that it is simply argon with 4s2, 3d4. Alright, so we got the electron configuration. What are they asking? How many orbitals are completely filled in an atom with the atomic number 24? Okay, well, here they are. Let's count them. How many are completely filled? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 orbitals that are filled. These are what we call unpaired electrons, and they are not completely filled. So, what do we say? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 orbitals that are filled in an atom of chromium. 10. And we said, what is the electron configuration? We already have that. It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. And we know that this is the same as the noble gas argon without going over. So if we wanted to write it as noble gas notation, we could say argon 4s2, 3d4. And since we know the item is chromium, we can identify it there. That's all you do.